All right, now I'm going to make a video that's going to help explain multiple transformations of functions. This is a much harder idea, and I will try to work this through with a few examples. So what I've done is I've taken the graph of y equals x squared, and I've applied two different transformations. I've changed b, this multiplier, to 2, and I've changed c, which normally affects the horizontal shift, to 3. Now let's just sort of look at one point and trace what happens to it. Let's look at this point 1, 1. Where does this point move to? It moves to 3.5, 1. Well, if we were expecting it to move 3 places to the right, it didn't. It didn't go. And if we were expecting, we need to really understand what order these transformations are happening in. So one way to think about 2 times x minus 3 is to first apply this compression or stretch, since a multiplication by 2 would normally shrink our graph in a horizontal direction. This point 1, 1 would move over to here, to the spot 1, 1/2. And that would be the effect of changing this b to 2. Once I'm there, I then move 3 places to the right, 1, 2, 3, and I get to where I need to be. So I can think about this transformation as first apply the compression, then apply the shift, and I get to where I need to be. I could also think about this transformation as actually being, I could take 2 times x minus 2 times 3, or 6. And then I could say, I'm moving 2 times 3, or 6 places to the right, so my point 1 moves all the way over, sort of outside my screen. Well, I can make it inside the screen. Moves all the way over to 7. So it becomes 1, 2, 3, 4, 5, 6. That's my shift of 6 to the right. And now I'm at 7, and now I need to compress by 1. Compress halfway, since my multiplier b was 2, and I also get to 3.5. So when I have y equals 2 times the quantity x minus 3, let's see here, when I have y equals 2 times the quantity x minus 3 for x squared. Whoops, I'm not doing this right. I'm going to cancel that part. 2 times x minus 2 times 3. My graph moves, I can think of it in one of two ways. Either I compress my graph first, my y value, my x value moves from 1 to 1/2, and then I shift 3. 1, 2, 3. Or I can think of distributing in here and saying 2 times x minus 2 times 3, or 6, and then I apply the shift first of 6 to the right, 1 all the way over to here, and then I'm at 7, and I compress and move to 3.5. The same thing would apply to this point here. I could move it 6 to the right and get it to 6, and then compress it and it moves to 3. Or I could first do the compression and it stays at 0, because my point 0 compressed halfway is still 0, and then I move to 3. So that's what's going on in this particular function. All right, now let's take a look at this function. Here I've made C2 and D3. So we would expect our graph to shift 2 to the right and up 3. And we can look at any individual point and say, did this one move 2 to the right and up 3? Yes, it did. Did the point 1, 1 move 2 to the right and up 3? Yes, it did. So this transformation with just shifts is pretty straightforward. What if we were to change this transformation slightly and make a -1? Then now the order in which we apply these transformations matters. And it really looks like this reflection happened last. We shifted this point here, 0, 0. We moved it 2 to the right over to the point 0, 2, 0. Then we shifted it up 3 to the point 3, 2, 3. And then we flipped the graph upside down from here. Or we could also have just flipped this graph upside down first and then shifted the points. Certainly that applies for here. What happens to the point 1, 1? If we move the point 1, 1, 2 to the right, it becomes 3, 1. Up 3, it becomes 4, 3. It becomes 3, 4. And if we now were to flip it over the x-axis, we would have the point 3, -4. But we don't have that point on our graph. So what was the order that would have taken this graph and applied these 3 transformations, the transformation -1, the transformation 2, and the transformation 3, and it really appears that what we needed to do first, and what we need to do first, is actually apply this effect on the A, on the compression. We needed to flip the graph over first so that this point 1, 1 becomes 1, -1, and now this is the point that moves over 3, 1, 2, 3, and up, wait a minute, this is the point that moves, sorry, up 3 and over 2. This is the, so I take the point 1, -1, and I move it up 3, 1, 2, 3, and over 2. So again, I need to work with this compression first, this transformation, before moving on these shifts. And if I don't apply the transformations in the correct order, I don't get the right answer. So to summarize that again, if I want to map the point 1, 1 on my original function and I want it to correctly map to my new transformed function, first I need to apply this transformation here, the transformation in A. I need to apply this reflection, because I'm looking really at compressions first. Once I reflect, this point 1, 1 would become the point 1, -1. Then I can apply my horizontal and vertical shifts. I can move my point up 3 and over 2. 1, 2, 3, 1, 2. And I get correctly mapped to my new transformation. Let's look at one last problem with multiple transformations. Here I've changed our parent function to x cubed, and the transformations I'm applying are D is 3, or a vertical shift of 3, C is 1, horizontal shift of 1, and B, the horizontal compression or stretch, is -1/2. So what is the order that we need to apply in order to have our points correctly mapped? Well, if we started with the point 1, 1, which is on our parent function, because B is -1/2, the first transformation is a reflection over the x-axis. This point here moves to here, and it moves there because of the negative. Now, but we're talking about -1/2, which means a stretch of twice as far. So the next transformation is to take this point which is at negative 1, 1 and move it all the way to negative 2, 1. All of that is due to B being negative 0.5. Now that we've done the compression, let's take a look at C. C is 1. Our graph now moves 1 to the right. D is 3. Our graph now moves up 3. 1, 2, 3. So in order to get the point 1, 1 to correctly match, we are going to first apply the reflection over the x-axis. Secondly, we're going to apply the compression created by B. Then we're going to do our vertical and horizontal shifts. And that is the order that we need to follow in order for one function to correctly map onto the other one.